right, looks like we're live. Thank you so much, guys, for joining me today. We're back with another Infinite Layers. Today, I'm with a really, really great team to kick off 2025. Someone that is not only really innovating in the tech space and also on EigenLayer, but they're also doing a lot of real interesting public goods type of stuff that I want to talk about a tiny bit down in the area that they're from, down in Argentina, around education and stuff as well. But anyway, I'm here with the co-founders of Align. So I'll let you guys jump in and give us a quick intro.
Awesome. Thank you for having us, Father. Nice to meet everyone. I'm RJ. I'm one of the co-founders of Aligned. My role is to do a little bit of everything, making sure things work and we move forward. Both me and Mauro actually come from Lambda Class. That is a company that has been working in the space for a long time, building in CK and distributed systems, in particular for crypto. And Align was born as a spin-off of this company with people that were working in the company. Both Mauro, me, Fede, that is the founder of Lambda Class, and Diego are all co-founders of Align. And everything was bootstrapped inside, and we spin off a year ago, more or less. And yeah, my background is in engineering, and then I migrated to helping everyone in the team.
Yeah, so that introduction, I think, summarized it perfectly. I work in Lambda Class on cryptography, so cryptography engineering. Also with Diego, that was more on the research of the cryptography part, and then we co-founded Align with Hershey and Fede after seeing some problems in the industry that needed to be solved. We decided to take those problems head on and start fixing them.
Amazing. Well, great to have you here. Can you give us maybe a quick introduction to what Aligned is and how long you all have been working on it, and then we're going to dive into a presentation to go in a little further.
Yeah, sure. So yeah, we'll start with what Align is, and then give a little background of how we ended up building Align. Because I think if you understand where everything comes from, it's easier to understand what we're trying to achieve and what we're trying to build. So Align is the first product of Align, because right now we're going to build a suite of products and infrastructure, is a CK verification, and it's called the fast mode. So it's an infrastructure with the sole purpose of verifying proofs outside of Ethereum and trying to batch a lot of proofs and submit the results directly on Ethereum by lowering the cost of each proof. To give a very simple analogy, what EigenDA, for example, is trying to solve for data availability, Align is kind of trying to solve a similar issue, but for CK. And we believe CK is going to be really important for Ethereum, and we're trying to offer an infrastructure that can help CK get more used and adopted for developers around Ethereum. And our background is also important to understand why we're building this infrastructure. As Mauro mentioned, in Lambda, we have been working a lot in CK for the last couple of years, and we noticed a very common problem across all of the projects that, for example, Mauro and Diego have been helping. And the main issue is verifying the proofs directly on Ethereum. So Align was born as a solution to many of the problems we have been seeing in the space for the last couple of years. And back in February, end of January of 2024, we start coming out with a very simple design and a white paper to build this infrastructure. And at the same time, we were studying EigenLayer, and we noticed, hey, we can build a brand new infrastructure, actually bootstrapping and using the technology of Eigen to make something new and useful. And this was a project that have been building for last year. And we went live in the last week of November.
Got it. Mauro?
Yes, to add a little bit at the motivation of this. So we will dive a little bit deeper, I assume in a couple of minutes, but as everybody knows, like Ethereum is a very expensive machine. You do 2 operations or 3 operations, and the cost of using the network skyrockets very fast. So one easy solution, or that has been around for a while, is okay, don't do the computation in Ethereum, do a secret proof outside. You can do as much computation as you want, like process something for hours if you need it, and then use the result in Ethereum. But even like just verifying this proof is still expensive. So the purpose of Align here is to reduce this cost, to enable everyone to offload the computation, do things cheaply, and then go back to Ethereum and pay almost nothing to do whatever they want.
So before I start diving into more detailed questions, I think we should jump into the presentation because it's probably going to answer a lot of those, and then I can go into more detailed stuff that isn't already covered there.
Perfect. Let's see if this works. Can you see the slides?
Looks great.
Perfect. So I will start and then with a general introduction of Align, and then Mauro will explain more the architecture and the basic flow of how developers usually interact with Align. So as we mentioned, Align is a secret verification layer, and the first product we're building is the fast mode. So the whole purpose or vision of Align is to help Ethereum accelerate its roadmap. As Mauro mentioned, SIG is going to be a very important already part of scaling Ethereum. And we noticed that in order to use this technology that actually scales Ethereum, we need to help that technology scale as well. So we're building different products and infrastructure around this core vision, trying to remove complexity and allow developers to access this technology in a very simple way and without having to worry about costs. So if we are moving towards a CK-enabled future, the whole idea is to start by offering people fast and affordable verification for any of this tech, because CK is moving really fast and we have constant new advancements and news. But developers usually are not 100% sure which technology they need to use and which one is going to be the best. So part of our core idea and vision was to try to integrate as many CK technology as we can and offer a very simple way for everyone to use any of them. What I mean is, you have, for example, the CKVMs RIC0, SP1, people sometimes write their own CK circuits, and there are many options in the market. But we need to build an infrastructure that can support all of them. So if developers in the future want to move to a new technology, they don't need to change the whole stack. And the biggest problem we have is we thought the problem in CK was with proof generation. But in the last year, what we have seen is CK is already accelerating. Like there are multiple teams working in improving developer UX when you are using actually CK for general computation. And also the speed is getting really good. At some point, we will get real-time proving. And if proof generation is not going to be the bottleneck, the next big bottleneck we have is actually verifying and posting the data directly on chain for any. So the verification of zero-knowledge proof directly on Ethereum. And we want to build on Ethereum because we are very aligned with the mission of Ethereum and because we also believe developers want to build on top of Ethereum. From a business perspective, we see Ethereum kind of as New York, and people want to build financial products in the biggest financial hub. And Ethereum for us is the same, but for crypto. So we want to offer tools so more people can build directly on Ethereum. Like the verification costs are extremely high, but in particular for many applications that are not CK rollups. Not every team can spend millions of dollars per year on verifying or raising millions of dollars to create an infrastructure that can do the proof of aggregation on their own or spend money on research. So this cost needs to get lower so more people can start building and experimenting with CK. And to give a very rough idea on the cost today for verifying a proof, verifying any kind of proof, and probably the cheapest one, it costs at least 15 transactions in Ethereum of moving an ERC20, ERC20 transfer. So, and this is for the cheapest kind of technology in CK. There are many new technologies that even Ethereum today doesn't support. But with Aligned, will allow any of these technologies to work directly on Ethereum. So the solution we came up with is having an infrastructure on top of Ethereum with the sole purpose of verifying proofs. So we can actually offer something that was designed from scratch to just solve this problem. We don't do general computation. We do not offer any other service rather than receiving proof, verifying them, batching them, and posting it on Ethereum. Mauro will tell a little bit of why this is important and how this is actually lowering costs. But the nice property of Aligned is that only by offering one simple thing, we can actually spend most of the resources of the decentralized network to lowering cost and making things as simple as possible. And the other thing we notice is that while building this infrastructure, there are many other tools and products are missing in what we call the CK modular stack. So around the line, we'll build on top of it many other tools and products that will help people directly access Ethereum using CK. So we're building kind of a CK modular stack, and the idea is to bring developers unlimited access to Ethereum. Like we're in the business of allowing people to access without limitations Ethereum. And these are some of the products that we'll build in the future. First, the proof verification layer, that is the fast mode that is already live. Then we are going to offer also a proof aggregation system, a simple rollup stack where you can easily launch a CK rollup. And we're also building a bridge that was one of the first products we came up a long time ago. And yeah, we started the year with the white paper. We had free testnets. EigenLayer, of course, helped a lot there, and all of the operators of the ecosystem. And right now, we're very happy because we ended the year with finishing one of our biggest milestones, as was mainnet beta. And we have already 50 operators. We have been verifying proofs. We have more than 2,000 proofs verified. And we have almost $6 billion in risk-take ETH, thanks to Eigen. And I think one of the biggest advantages of using Eigen is this part was not the biggest issue we had to solve, because we can easily bootstrap the network on top of EigenLayer without having to worry about doing everything on our own. So the security of the system is completely backed by Eigen, and it has been super simple to integrate this part. So Mauro, I will let you continue.
Yes. So you can move to the next slide if you want to say, but the core idea, I don't want to confuse people with all the design. I will give it a very quick summary. Is that the only thing infrastructure does, as I said before, is verify proof. And the good thing about verifying proofs is that you don't have dependency in time of things. Like usually when you build a blockchain, you have a lot of dependencies. If I transfer money to Arshey, I cannot transfer the same money to another. So it matters what operation comes first. Here in Align, it's just proof verification, so everything can be run in parallel, and you can go really fast and have an insane amount of TPS. And yeah, so in this case, we are using EigenLayer, so the ABS only verify proofs. And the only question is, well, since the users don't have enough volume of proof by their own, they might want to get them all together. So we have a batching service that joins proof from many users and solves them all together in one task, in one big task. And then the result get posted to Ethereum. And once it is in Ethereum, you can use it. And that's it. I will talk a little bit how we will improve this in the future, but this is the current version. And now let's say I'm a developer, and I want to use this. So the first thing that I have to do is to create a smart contract. And as I said at the beginning, the interesting part with CK is that instead of writing the expensive parts of your program in Solidity, that you create a program that uses CK and does all the computation that you need, as much as computation as you need. It doesn't matter. And then you create a proof of that and send that proof to Align. You wait a little bit and you get the results. You send them the results to Ethereum, and then you can just continue operating as if you have done everything in Ethereum. And you don't have any problems because this is backed by cryptography. Like the guarantees of CK are enough to say, okay, this output is the result of doing these operations. In the case that maybe the users don't want to do these CK proofs, or that you have a protocol that has to match, for example, orders like a swap or something like that, you can complement CK with intents, where the user sign their intent to do something, for example, exchange some Ethereum for USDT or USDC at some value, and then another one has the complementary intention, and someone matches the orders, and it gets solved and creates a secret proof, for example, and then send it to Ethereum. And in that case, the user doesn't have to generate proof. They only need to sign an intention to do something.
The workflow is super helpful to understand better how to use it as a developer. So that was nice. Thank you.
Yeah, thank you. So yeah, and this is the cost. Like the cost of verification of a proof, it depends a lot on the kind of proofs. For example, as the start ones are one of the most expensive one. It takes around 5 million gas. Grok 16 takes 250 hundred. So yeah, depending on the type of proof, it is more expensive or cheaper, but Align is always cheaper because like the cost is independent of the amount of proof. So we actually use an economy of scales. The more proofs our system have, the cheaper it becomes. That's very magical.
Yeah, just to add one thing there that is important. One of the reasons why we believe also offering many type of that we support many type of proof is because these benefits on the throughput of proofs by allowing people who are using, for example, I don't know, Starks and people who are using Grok 16 proof under the same batch, every single application, doesn't matter which technology they're using, they get benefits from the economies of scale. That this doesn't happen today because most of the big rollups, they do aggregation on their own. So what Align is doing is unifying many of these technologies under one single infrastructure. So it should be easier for Align to start benefiting directly from economies of scale, because it doesn't matter which type of proof, every single one of them will be under the same batch. Mauro, I don't know if you want to go into
this is a use of Go. I can show you, for example, a small application if you want.
Yeah, that would be really cool.
So let me get this. So for example, this is an application that what it's going to do is ask me some questions. If I answer them correctly, I can send a proof that I know the answers and get an NFT. So it's just a toy application to showcase how this works, but of course you can do any kind of application. So hopefully I remember the questions. So who invented Bitcoin? Assuming Sriram is not Satoshi, I think it's Satoshi. This is a hard one. Largest ocean on the earth. I think it's Pacific, hopefully, and the most line color is green. And this is generating a proof locally using a Rust prover. And after generating a proof, it will send it to Align, then to a smart contract that. The system asked me for if I wanted to actually pay for it, and I say no, so it didn't continue. So let's go again. Satoshi Pacific Green.
Mauro, this is in Holesky, right?
This is working in Holesky, so if you want to try Align, you can use Holesky. Of course, you can also use mainnet, but Holesky is going to be cheaper.
Right.
Yeah.
And I was doing a bit the Explorer that is working in mainnet and Holesky, and you can see all the transactions and everything that you need here. This will take around 40 seconds, 30 seconds. It depends on the throughput of the network until the task gets resolved.
So when this proof is being sent, and if there are like 100 other proofs being sent from other developers, are they essentially batched together?
That's right. That's right. They all get joined in a batch and they get results together. And right now, we are using a batcher of a line, but in the future we will also decentralize the batching process in the AVS, so that you can send the proofs directly to the network and it gets dispersed through all the operators, and they create the batch and then it gets solved. I'm really excited about that. We are working on that, but it's going to be in a future release.
So is one of the reasons why it's so less expensive is because of the batching? And I'm guessing the combination is like number one, batching, number two, all of this is done off chain. And then you combine those two things and you just have a less expensive, more performant system.
That's totally right. Yeah. The batching helps a lot. And of course, if you are using one of the expensive CK proof systems, it also benefits on that, because here the verification is done through the WLS services of Fagan that are really cheap. Okay, so I claim an NFT. I got a transaction hash and everything. So I can actually show you in Chainlands that an NFT was minted, probably just recently. No. Okay, let's go to the dashboard. It should be around here.
If you mean the CK quiz NFT, please don't ask us if you will receive anything in the future. We have been getting annoyed by many questions. This is a tutorial. It's not anything else.
It's to showcase an application. The NFT has no value, so please don't farm it. We don't even look at this. It's just for people to create their own applications. So okay, so we can see here that there is a freshly mint NFT, and it is the one that I shared. And if you want to check, we also have an explorer that has been live for a while. Yeah, you can check all the data in mainnet or Holesky. We are always improving it. But yeah, here you have the patches, and probably in one of these, my proof is somewhere over there. Actually, I have on the terminal the proof, and I think this is a batch. Pretty sure. Yeah, so this is a batch that contain the proof I just sent. Yeah, that's the demo. If you are interested in learning more, like check out the documentation, everything is there, including how we did this example, how to do your own, how to use the SDK. The SDK is being worked on. We are always improving it. Right now, it has some clunky parts, but hopefully in just a couple of weeks, it should be much better. This is our first version. We are iterating and improving every week. So yeah, that's all on my side.
That was very, very concise and helpful. I think that to kind of go through that. I think anyone that watched this will have a really good understanding of Align. I do have a few questions, but before I jump into the questions, is there anything else that you want to add or anything, RJ?
Maybe Mauro, can you share again the Explorer 1 second? Because I think it would be good to show, hey, this is the batch. Like, it's not an abstract concept. Mm-hmm. You can see that there's some proofs in there, and we can show the two main steps.
Yes. So this is information of a batch. It has a hash. It has some proof on it. I think this should be ours, the one I have just sent. If I go to the terminal, you should see it. It exists on, of course, on Ethereum Holesky. So you can see that there was a call to the function that is create task, and then a resolution from our network. So yeah, I don't know, Hershey, do you want to focus on something in particular?
Yeah, I mean, what I think is important here in the batch is to understand that, for example, in this case, we have 11 proof, And the main benefit of Align is, as Mauro mentioned, we're verifying one BLS signature, aggregated BLS signature from the operators using the Eigenlayer smart contracts. And we are saying, hey, all of these proof that we verified off-chain in this decentralized network are valid. We will only post them on Ethereum if they're actually true. So instead of verifying each one of them, what we're doing is saying, hey, Ethereum, check this BLS signature. If it actually has more than the minimum quorum, more than 2/3 of the operators of our network saying that this batch is actually correct, we're saying, hey, every single one of these proofs are actually true. So that's actually the magic behind the scene, or the way we can actually lower the cost. By verifying that signature, we can say, hey, here everything's valid. We can reduce the cost by making sure every single proof pay only a small percentage of that entire cost. And the interesting thing as well is the BLS verification signature cost in many cases is lower than just verifying even only one single proof.
Wow.
So even if you have only one single proof, in many cases you're already reducing the cost.
That's crazy. So even without the batching?
Even without the batching.
Yeah, that's right. For starts, that happens a lot. Well, I didn't want to dive a lot into this, but right now there are a lot of research in new proving systems that goes really fast in specialized hardware, that is Venus, for example. They cannot even be verified in Ethereum because it's so expensive that it doesn't fit in a block. And here you can use it. Those are like the fastest proving system that we have. At least with the specialized hardware. So we don't know what the future will bring, but if we keep going in that way, this kind of solution, there will be the only possible solution to use the new kind of proving systems.
So I have a bunch of questions, but I'm going to start with a couple, and we don't have a ton of time, but I'll probably go over about 10 minutes of questions maybe. But the first question would be this: like, as this technology advances and improves, new research comes out, is Aligned? I mean, I'm assuming the answer to this question is yes, but the way that Aligned is essentially engineered, and that is an ADS, you all can iterate, improve, and ship like improvements and updates a lot faster, as opposed to maybe like a traditional protocol. And is that something that you all like are keeping in mind, and kind of as things come along, and you can make Align faster and better and cheaper based on not only your own research and advancements, but also advancements in the industry? How does that kind of play into your design?
Yeah, exactly. Like, I think we could say, I want to be careful because we're usually conservative with the tech, but we can say Align is kind of future-proof, right? If there's a new technology in CK, we should easily be able to integrate it directly on the fast mode. On the proof aggregation mode, I think Mauro can explain better, it's a little more tricky, but for this particular infrastructure is already live, it should be very simple. Why? Because the software that is running in the operator is calling the library directly of that tech. So the client of the operator, the only thing it does is it says, hey, I received this batch, and this particular proof is, for example, from SP1. What I need to do is call the Rust library from SP1 and say, hey, verify this proof. Like, we don't need to do, in that part, it's only kind of like an integration. We shouldn't have to innovate on our side in order to allow a new technology. Maybe in the future there's some tech that could add certain constraints, but that's why we can easily iterate and iterate new tech. And also, by not having the constraints of DVM, we can allow tech that it was not even possible to use on Ethereum with Align. Like Mina is building a bridge on top of Align, for example, and they have a proof system that the math behind it is not supported on the EVM. So Align is actually the only way we can actually verify proof of Mina directly on Ethereum. And maybe in the future this will happen with a light client from, I don't know, Aptos. Like, we don't know exactly which tech, but we know that having something that is only focused on CK, it will be easier to integrate things that people demand.
So you talked about fast mode, and you've talked about, I guess, the aggregation mode. Maybe I've misquoted that, but Can you kind of talk about the difference between fast mode versus the other, whatever you would call that mode or type?
Mauro, I think you are the best guy
Yes,
for explaining this.
I can explain a little bit. So the ABS mode relies on the economical security of our ABS, which for many applications is going to be more than enough. As you can see, we have like 5 billion USD. So it's a lot of money. It's a lot of security. But let's say you want the full crypto economical security of Ethereum. That is all of the stake of Ethereum, not just a fraction of it. So what you can do is to do a similar batching, but using cryptography. What you're going to do is to generate proof. For example, let's say I have 2 proofs. Then I'm going to generate a proof that I have verified 2 proof, right? And send that to Ethereum. If I do that, I'm making the cost of verification of 2, the cost of verification of 1. I'm batching it through cryptographical tricks instead of this ABS system. That has the advantage, as I said before, that you can rely on the full economical security of Ethereum. It has the disadvantage that you cannot do it with all the proving system. You are adding latency to your system because all these techniques require extra processing. So you need more hardware, more latency in your infrastructure. And it might not work, or it doesn't work with all proving systems, and it's not trivial to aggregate. Maybe the star proofs are really nice to aggregate between themselves, but when you add a proof of another type, then you cannot put them together. So it has advantages and disadvantages. So we want to provide all the alternatives and then let the users pick the one that suits their needs.
Got it. Yeah, that makes sense. Totally makes sense. So there's kind of like different trade-offs that they can make in performance and latency and cost and decentralization, essentially.
Yeah, that's right.
Exactly.
Cool.
The whole point is offering more options. Like
Yeah.
developers should be the ones making the trade-off. Which one is to make them offer them the different infrastructure so they can choose.
So when building Aligned, what were some of the challenges that you all have run into in building something like this? And is there anything else that's out there that you would kind of compare before you all started building this that existed that would be, similar?
I think that there are different kind of challenges, right? I think the technical one, Mauro has been in the battle fighting with the other engineers and can tell he can tell you a little more another stories. But from in general, what we have seen is one, CK is moving really fast. At the same time, we're building infrastructure for CK. Luckily, as we mentioned, we have an infrastructure is flexible enough so we can keep up with that. The other one, in general, I believe with the space is education, right? Explaining developers, hey, this is why it's useful. This is not just people who like math to try to use or force a technology in particular. We actually believe CK is going to be not only useful for Ethereum. We have been talking with people who want to use CK outside of Ethereum. It's going to be used everywhere, in our opinion. And for example, one of the use cases I love is CKTLS. That there's a project, Opacity, for example, from the EigenLayer ecosystem. And we know this will unlock many type of different use cases and opportunities. And explaining that to developers has been one of the main challenges. Luckily, because everything is moving fast and the technology is improving a lot, I think the product in itself is showing, it will show developers why is it useful and why it's easy to build. And the developer experience has been one of the main challenges, making things simple,
Totally.
Improving the tooling. We need to be very transparent. One of the things that we internally need to improve is documentation. Aligned documentation, we know with Mauro and the team, we need to keep iterating and improving. So I think that's the hardest part.
Nice. Yeah. I think that getting all of the things right is always challenging, but prioritizing developer documentation once the product actually works is very, very high value for sure. And I think like we're starting to see with, I think with the AI stuff, and I want to ask you a little bit about AI in just a moment, but I would say the reason that some of these AI frameworks are taking off, it's coming down to developer experience. It's not the quality of their product, actually. Like some of the products that are becoming really popular are not that good, but they're becoming popular because they're very simple to kind of get up and running with. And I think that once you give that a developer that tool that they can become successful with, and they become familiar with what your product does, then they can go in and kind of like make improvements and start building the thing that they want because they've kind of understood how it works. And I think ultimately you don't have to kind of give them the most complex getting started experience. If you make the experience like really simple, even if it's not like a real world use case, they become familiar with your product, and then they stick around, and you end up having a larger number of developers in your ecosystem. Let's talk about AI for a moment, and then we'll kind of wrap it up. How do you feel that ZK is going to play into the whole AI narrative that we're seeing take off right now?
Okay, I think there are two like different roads. This is my opinion. Maybe Mauro has a different one, but there are two avenues in my opinion. One of them is actually proving the inference, for example, of a model. Let's say what you want to do is prove, for example, that you use ChatGPT and they're actually the response you got is from that particular model because what you're doing is proving the computation of the inference of that model. Now, that's what I always thought that would happen, but what we have seen, and this is actually thanks to you and other and the EigenLayer ecosystem, and I think Ayesh, he's also helping there a lot on opacity, is I believe we will see more proving that actually a response or that you got from a prompt comes from a particular server or a particular service, and CK is going to verify those things. I was surprised. I never imagined that was the way things will play out, but it's what we are seeing that developers are doing, and the way they are interacting with this. So that's the first interaction we're seeing. But there are teams working on making. I think there's a team actually working on a proving system just for machine learning. But in our opinion, this will be very important because people will demand knowing that the model they are actually using is the model that the service is selling. Because in the future, you want to use the best model out there, and you want to verify that they are not using something else. They don't have monkeys on the background typing things on the keyboard, right? and the other thing is privacy. Maybe in many cases you want to prove that certain computation you did with a model, the output was correct, and you don't want to show, for example, certain information of the model or certain information that was used as an input.
Nice. Yeah, I agree with all of that. And it's cool to kind of see it starting to take shape in real world use cases. And it is interesting because like a long time for the longest time, it's been more about proving that the content was human, right? Like, so for instance, you submit something to your college, they're trying to make sure that it's not AI, but now we're trying to make sure that we can also prove if it is AI for the agents and stuff, which is flipping the whole thing on its head. The last question I want to talk about is having to do with the proof generation and like just out of curiosity, what frameworks and what things that people are using these days for like what is the most popular like frameworks and tools, and maybe also what are kind of the up and coming or bleeding edge for proof generation.
Mauro is the cryptographer.
I can talk a little bit about the history. What I see is the following: you have some developers that they learned CK probably years ago, and they tend to use things like Circom, like you write your own circuits, and that kind of things. Those systems, for someone who is new, they are really kind of arcane. They look weird, and you don't understand what's going on. But if you already learn them, maybe you are still using it. I think the future is probably moving to Rust provers, what we call secret Rust provers. That will be things like RIC0, SP1, Lita. They have different techniques, but the core idea is you just write Rust, is your common Rust programs, and then you make a CK proof of that, and you don't have to learn anything about CK. I'm very bullish on that kind of tech. I think that's probably the future and the way to onboard more users to CK.
And if someone is using SP1 or if they're using Rosero, they can also use Align, correct? You guys support all of those.
That's right. Currently, we support Rix0, SP1, NARC. We have Nexus in a way. It's more experimental, but we have it there and others.
Awesome. Well, that's been, I think we covered quite a bit. I think that I got all of my answers or my questions answered, and I had a list of those, but you answered a lot of them in the actual presentation along with like the conversation that we had afterwards. But before we wrap it up, is there anything else you want to add? And also, what developers need to know to kind of get started in terms of like social media presence, documentation, websites, and just general community resources and things like that?
Yeah. If you want to join us and kind of get aligned, you can follow us in Align Layer in Twitter. Now we have also the foundation, the Align Foundation in Twitter. And the best place is, if you are particularly for developers, the best place is our Telegram group. We're mostly more active there. We will answer quicker there. And we have been doing hackathons in the past as well. Like correct me if I'm wrong, Mauro, but I think in November we did a very big hackathon on our own. Another, I think he was one of the judges. So we'll keep doing that in 2025. And we'll use that, of course, to get feedback and improve the product. And if you want to start doing a tutorial, you can go to our documentation that is docs.alignlayer.com. And you can find there the CK quiz that Mauro did today, for example.
Yeah, and also probably read our articles on Twitter threads. Like there was one we did a couple of days ago about Intents and CK. They are not strictly about using Align, but I think they are trying to open the mind of the developers to say, okay, how can we design new architectures with all of this technology, and then you use Align. But first try to get into all this new tooling of intents, CK proof, and everything.
Nice. And I think that of all the companies that are in crypto, Align has, in my opinion, like the best name because when people say aligned, it's like, you know, it means so much. So I think you guys crushed it with the naming as well.
Thank you.
Awesome. Well, yeah.
We had to convince Sergey. It was difficult.
I was not convinced at first. But that being said, I was the one with the green rectangle idea. After they convinced me.
And I love the green rectangle as well. And I love your branding and design stuff. Like, I think that the last hackathon I was at, the swag that you had was like a t-shirt with the white paper with just a green rectangle going through it. I love that.
Yeah, we have the ecosystem team did a great job with that. And that the white paper idea I caught on. And then I think other projects started doing it with their own white papers. The only disclaimer about our white paper is still in draft. We need to sit down and update it and making sure we cover all the details.
Yeah. Maybe as one last thing, like we have a very engineering like approach. There are places in the white paper where we could have designed something that is like more complicated, that has maybe a less trust assumption and everything. But our mindset is, what is the minimal thing that we can do to ship this to production and then iterate? Yeah. So everything that you see in the white paper has been in production at some point, and sometimes it happens the other way around. There are things in production that are not in the white paper.
Very cool. Another last call out is I've gotten to know Jeannie, who's on your team, and she's really great. So follow her. She's kind of fun to follow on Twitter as well. But definitely go to Aligned and check out some of the other team members. Follow all of them. That always talking about some really interesting stuff. And I think you all are on the bleeding edge of ZK for sure. So thanks so much for joining us today. This has been really helpful. If you caught the end of this, you can go to YouTube. Tomorrow we'll have the whole video there, and we'll be sharing clips from this from the Build an Eigen account as we go along. So I hope everyone has a great week, and check back with us next week for another Infinite Layers.
Thank you.
Thank you, Nadar. Thank you, everyone.